Today, we're going to learn how to do this. And we're going to learn how to do it with 3 different methods. With a latent consistency model, SDXL Turbo, and with StreamDiffusion. Now, we're going to learn how to do these things with a Mac OS system. In this case, it's M2 MacBook Pro, but the steps are essentially the same whether you're using a Linux system or Windows. So you can follow along regardless. If you have a CUDA GPU, then you're going to be in really good hands because anything that we do today is going to be blazing fast for you. The MPS system here in the Mac is pretty good, but if you have a CUDA GPU, a lot of these models are optimized to operate with a GPU. So lots of you have probably heard of automatic 1111111111 or ComfyUI. These are really great tools to do a lot of the stuff that we're going to be learning about today. But I like to code, and so in today's tutorial, we're going to learn how to do some of those things through code. I like the clickety-clack of the keyboard. Yeah. The LCM line of models and SDXL Turbo are a super recent set of distilled models that make generating images super fast with very few inference steps. StreamDiffusion isn't really a model, it's more of a way to optimize the generation process for a lot of these models. And in fact, we're actually going to be using LCM behind the scenes with StreamDiffusion. It's essentially made for CUDA GPUs, but there's a hack to make it work with MPS, like for this M2 MacBook Pro. But if you are interested in the CUDA for how to use StreamDiffusion, I also got you covered. I'll just tell you which lines to uncomment. Take what you learned today and run with it. Go crazy. Start some new art project, do something weird, something abstract, or something normal. The idea is that all the things that you learned today can be modified, you can innovate upon them, and do interesting things. I mean, one simple idea is you get a projector and when next time you have a party, you have a section where there's like some sort of generative art thing in real time that people can play around with. Gives people something to do. Anyways, without further ado, let's play. Before we begin, I'll briefly describe how these diffusion models work. So let's just assume that the entire world is made up of noise. Just noise. Red, green, blue, random values of pixels on the screen, on paper, anything. Just random noise. But if we assume everything is random noise, what if we could start shifting those RGB colors up or down and do it in an organized way such that we sculpt an image from the noise? Essentially, that's what these models are doing. And that's called reverse diffusion, where you go from noise to some sort of clear image. During training, these models are basically just given perfectly good images, and then you add a bunch of noise at different levels. And the model learns how noise gets added so then it can get it subtracted. So we go from forward diffusion during training and reverse diffusion during inference. Okay, so we're gonna need to download some software. And I know, downloading software is always where things start to break apart. But don't worry, I got you covered. The links of the things you need to download are in the description, and we're gonna briefly go over how to download them. It's very simple, these are easy to install. So, one of the things that we need is going to be some sort of text editor. I like VS Code. You can go to vscode.com and then you'll see it's super easy. You just click on one of these items depending on your system and you're done. We're also going to need to install GIT LFS. So GIT LFS is basically a system for allowing you to download large files that are basically in the GIT format. We're going to need to install this because we're going to be downloading some of those models and we want to use a terminal because we're going to be hackers. So again, it's very simple. You just install it by clicking these buttons and going through the steps. Finally, we're going to need to install Python. Same process if you have a Windows, Linux, or Mac system. You're just going to go to like the specific page. So here, Python source releases. That's if you have some sort of Linux system. For Mac OS, you would go here. And the Python version that we need for the LCM and SDXL Turbo models is going to be 3.11.6. Now for StreamDiffusion, you can download 3.10.11. So here I'm in terminal. You can just go down here and click on this button. This would be Command CMD in Windows. And what you do is now once you have Python installed, what we want to create is a Python environment, a virtual environment. So to do that, all we have to do is write Python 3.11, because we're doing the LCM and SDXL Turbo environment first. And then we just do -m venv env, and then the name of the environment. So we can call this LCM SDXL Turbo venv. Next, we want to create the environment for StreamDiffusion. So similarly, we go 3.10 m venv, but this time we can call it StreamDiffusion venv. Okay, one of the reasons I like this is if I do ls, which basically just says list the files that are in this current directory, you'll notice that we're going to find two folders, LCM over here and then the StreamDiffusion. Now you're going to notice that I have these two text files here. So to make your life easier, I prepared these requirements.txt files so that you can install the packages that you need without having to worry about dependency issues. We want to activate the environment, so we're going to go to LCM SDXL Turbo, and then we're going to do venv, and then we're going to go to bin, and then you'll notice if I just hit tab that it'll open up what's available. And to activate the environment, so now we get inside this new virtual environment of Python, we hit enter, and now we're in there. And you'll notice how there is now a parentheses next to your username. So now I will do pip install, and then I do -r to tell it that we're going to be using a requirements file, and then we're going to do SDXL Turbo and then requirements. And then you hit enter. Now this is going to take a little bit. It might be super fast, it might be super slow, depends on your internet connection, but this shouldn't take too long. In the meantime, while our LCM environment is being made, we can Command T to create a new tab, and we can start creating the virtual environment for the, install the packages for the StreamDiffusion. So to do that, we will just check again where we are. Okay, so now we need to activate our environment, and we install the packages inside that environment. Source to activate it, StreamDiffusion venv bin, and activate. So now then we do pip install -r and then StreamDiffusion requirements for you. So the next thing we want to do is we want to start installing the models. So the models are going to take a while, unfortunately. They're pretty big. You want to make sure that you have about 120 gigabytes available. So if you don't have it on your computer, get an external hard drive and throw them in there. In this case, I'm going to create one on the computer. So to do that, I'm going to do mkdir, and I'm going to call this models. So you see here, now I have a models folder, and we can double check here. It's created, it's now empty. And I'm going to go into that folder using the terminal. So I do cd models. So now that we are in the models folder, we're going to need to install 3 different models. We're going to use GIT LFS for this, and we're going to install LCM, an LCM, SDXL Turbo, and a Controlnet. So to do that, I actually have prepared a separate text file here, and you just need to, these links will also be, this text will also be in the description. Just copy and paste it, put it in your terminal, and just let it ride. So while we're waiting for things to install, I might as well tell you a little bit about where you can find these models. So you can go to Hugging Face, which is an amazing, amazing place. People at Hugging Face, thank you so much. You guys are doing really great work for everybody. Really appreciate you. So you can go to Hugging Face, and as you can see here, I have the models that we're going to use GIT LFS to clone into or download into our models folder. And you can search this entire website and find tons of really cool models. You just have to make sure that they're compatible. And then we don't actually need to install anything for StreamDiffusion, because for StreamDiffusion, we're actually just going to be using the LCM DreamShaper 7. Okay, so now we have one of these models finished installing. And you'll notice if I go to the models folder, it is now over here. This is perfect. What we're going to want to see at the end, after you do git clone for those 2 other models, we're going to see them fill up in here. So just as before, we're going to go and copy these links. Although, since we're already here, I can show you how to do it from here. You literally just go here. We need canny. So we're going to go here. We're going to Control C or Command C, and then we're going to git clone, and then we paste the link. And then boom. Okay, great. Now we have canny downloaded. Now we just need to download one more. So we're going to go over here. We're going to go to SDXL Turbo. We're going to copy this link. We're going to go git clone. And then boom. Okay, great. All the models are now downloaded. So now we can start to code. Instead of typing each line in real time, I thought it might be useful to just have a reference script, and then I explain it, and then we can create a new script based on that reference script. So in order to use the webcam and take advantage of these really fast models, it's really as simple as having a script that opens up the webcam, and then when we have an image that's taken from the webcam, we send that through the diffusion process and then send it back so that we can display it. That's really it. What makes this really cool is that it's really fast now that we have these distilled models that make things super fast. So the first thing is I'm just going to explain how the webcam thing works. Honestly, I didn't really do much here. I only added a few lines. You know, if you just search for webcam OpenCV, you're going to find this. I mean, I'll do it right now. OpenCV webcam. And you'll see there's code already. So I basically just copy and pasted this, and I only modified a few things. So what I modified here is, I'll explain these functions at the top here in a second. So what I modify here is, well, first, the camera ID. So the default is usually 0, so that's the internal camera of the laptop. But if you have a USB camera or some other camera connected, then you might want to switch this to 1 or 2, depending on how many cameras are detected by the computer. This line right here just asks, hey, pick a camera. The next thing is that we want to put in a while statement. So that means it's always running. And as it's running, we're going to use this class, this method, the .read, and it's going to return true if it's successful in opening the camera, and image. That's the frame by frame image that we're getting in this while loop. So the thing that we can do is we can literally just grab that image and then run some function on it, process it, and then we display that resulting image after it's been processed with this other method that is part of OpenCV. And that's basically it. So now I can explain this. So here I'm just asking OpenCV to tell me what's the resolution of the camera that's internal to the MacBook. The next thing that I do is I just divide, I can now set what the resolution is going to be for the webcam by just grabbing that width and dividing it by 2. I like it smaller because then we have more space for Stable Diffusion. So why don't we make a new script, and we can just copy and paste that. I know it's a little silly, but let's just do it. And we can call this webcam, and we can call it the same thing, webcam simple. And so what I did here is I have 2 different ways to process the image. So the first one is just processing the image as gray. So I'm going to copy this, and I'm going to put it over here. It's important to have the functions at the top, because you define them at the top so that you can use them at the bottom. So now we have this script. I'm doing Command S to save, and I can go into terminal, and now I can just cd out of it, aka move out of this folder, and you can do that by doing this. And now I'm in the main folder, right? Here are all my scripts. So now, since I have the environment activated, I can run Python in it. And I can just run webcam simple.py. And so now a screen is going to pop up, capturing the feed, and it's going to turn everything into black and white, as you can see here. So the next thing, so you can do Q to exit, or what I like to do is just go to the terminal and then do Control-C. Over here I have another method, and I'm just going to copy this over here. And this method is one we're actually going to use in our generative AI stuff. I'm going to use this method called canny, and canny is just an edge detection algorithm. And you can set the threshold such that there's more or less edges detected. So in order to give you an idea of what's going on when we're talking about Controlnet, so Controlnet was trained to be able to take images that have these edges and then use them as a reference for the diffusion process. So now I just commented out this line, and I'm going to hit this again, and now we're going to see an image full of edges. Very cool, right? Okay, great. So that's basically the most important part for some of this webcam stuff, right? Like, we just need to get the webcam to work, and then we basically just have something here, and instead of process image as edges or process as gray, we would have the generative AI aspect be the processor. Okay, next up, we're going to work on the script that runs the LCM and SDXL Turbo. So I know this looks like a little bit scary, but it's really not. So first we need to import all the packages that we need. ArcParse we actually don't need, so I can just delete that. We also need PIL. So a lot of the diffusion models, they like the image format to be in PIL. We also want from the diffusers library to import these guys. We actually might not need this one, so I might as well just delete it. I don't think we use it. We also don't really need this one. So at the end of the day, we only need these three. These classes handle loading of the model, the architecture, and all of that. So they do the heavy lifting for us. So we want to import those. And we're actually not going to be using the Controlnet Open Pose Detector, so we can actually also delete that. We want to import Torch, and what we're going to be using it for today, in addition in it being in the back end for the models, is we're going to want to determine whether we want to use 32 floating point numbers or 16, and we're going to be using 16. Okay, so next I wrote this little script, choose device, and this is a useful script. If I have CUDA, then I want to use float 16. If I'm using MPS, I also want to use float 16, so MPS can also handle 16. And then if you're following this tutorial and you don't have one of these fancy computers, that's okay. You can still do this, but you'll have to use float 32. Just a handy little script. So over here, at the top of the script, we have the constants. So these are the things that you're going to change to experiment. Everything else you can just keep as is. Over here you have the model selection. So if you want to use SDXL Turbo, you would type in SDXL Turbo. If you want to use the LCM, you would write the LCM. So for now, why don't we just do the LCM. We want to specify the locations of the models. So if you remember, we made that subfolder models, and in that we have these folders, these subfolders. And if you remember, just to prove it to you, models, and then we have the models over here. In order to ensure that there is consistency every time that we generate an image, because this is real time, there's multiple frames happening, ensure that you have a fixed seed for the process. So we also need this, also more of like a utility function. It just converts a NumPy array, an NumPy image into a PIL image. That's why it's called convert NumPy image to PIL image. So these models, they're made so that you have fixed resolutions at which they work best. You can do other resolutions too, but there are some resolutions under which they're trained. So you want to use these resolutions. So 512 by 512 is one of the main resolutions where Stable Diffusion 1.5 was trained. The newer ones are trained at higher resolutions. So we're going to be using 512 by 512. And so that's not the entire size of the webcam capture, right? We have a much higher resolution for the webcam. So what we're going to do to kind of make life easier, and you can modify this, we're going to create an image that's at the center of the webcam image. And anything that happens at the center is what's going to be sent to the models to generate an output. So that's as simple as writing a script like this. Basically, we create a mask, we find the center, and we spit out that mask. Here I call it the cutout. Oh yeah, and then we already saw this. This process LCM, that's the same thing as before. It's the find image edges. This is the canny thing that we talked about, that we just saw. It's just the edge detection. And we need this for the LCM. For the SDXL Turbo, we don't need to use Controlnet. So I have another function here that's very silly. It doesn't really do anything. It just spits the image that it gets back. But I created it because it's useful to have in some of the if statements that we use later. So in this method, what's happening here is if we have the LCM, we're going to use Controlnet. As you saw, we imported Controlnet model over here. We imported this from diffusers. And from pre-trained basically just says, hey, where is the Controlnet model? Tell me where it is. And so you tell it. Here it is. We set that up over here as a fixed variable. So we just like put it in. Then what we do is that we want to instantiate the Stable Diffusion Controlnet pipeline. So again, as I said, the diffusers library has a lot of these different types of classes, and they handle all the heavy lifting for us. In this case, we give them the location of a model. It's stored locally. I like to do things locally. We didn't have to download the models, but in case you want to go offline and do this at some rave or something for like visual effects or something like that, it's nice to have things local in case you don't have internet. In any case, there's this thing called the pipeline. That's just like the nomenclature that's used. There's conventions, and this is one of the conventions. And so same thing, we say, it's asking where is the model that you want to use. Okay, it's over here. It allows us to specify a control net. There's many different types. We specify the one that we have here. We named it right there. This to device is telling the pipeline to load this information into the GPU if you have one, or into MPS. Or if you don't have any of those, then just the CPU. And that's basically it. For SDXL Turbo, it's basically the same thing. So now I have two different functions here, run LCM and run SDXL Turbo. And they're essentially the same. So again, the type of convention and how the diffusers library works. Well, first we want to create the seed. So remember, we had that seed function over here. And the pipeline has many different arguments. And these arguments are the ones where we can do tons of customization. We can change the guidance scale, the height, the width, the image that we want to use as reference, the conditioning scale. There's tons of stuff. But we set these as constants up here so that when you want to change things, you can just go to the top and change it. Over here for SDXL Turbo, I fixed the guidance scale to 0 because that's how it works. That's what happened during the distillation process. And that's it. The last function over here just puts all these functions above it together. And as you can see here, I'm running this last one. Like this entire script, these are all functions and variables that have been named and set. But the magic happens when I run it. So let's look at what's going on here. So again, this over here is this function over here. All it's doing is saying, hey, what model do I want? Based on the defaults that we set up there. We pick it. Again, which type of processor do we want? Do we want to do the find images or the find edges, or do we just want to spit out the image as it is? It's useful to have this just so we can have some modularity. Then for run the model, again, choose this one if the model is LCM, or choose the SDXL Turbo if it's not. And if you remember, what's happening here is now we're preparing the webcam. So this is the exact same script that we had before. It's all the same. And then again, we have the while true. Again, just keep running through every frame. Just keep going. And for every frame, grab that frame. Here I'm calling it an image. And find the center of that image. Send that to get the cutout. So this is the cutout that we talked about. Now that we have that cutout, we're going to send it to the processor. So if it's LCM, it's going to send it to the edge detection. So after we get that cutout from the webcam, we're going to find the edges in that cutout. And then once we have that, we need to convert this back to the pill image format because that's what the diffusion model's like. And we send the model, the pipeline, and the pill image. And if you remember, that's just saying, hey, here's the pipeline. Use it right here. This ref image goes right there. Then another thing that's also kind of interesting about OpenCV is that the order of red, green, and blue channels is a little different. So we're used to hearing RGB, but I think due to some conventional thing that happened way back in the day, the formatting that this library uses is BGR. We have to convert it back to that format in order for it to be viewed without any color changes. And then, just as before, once we have that resulting image, we throw it into CV to have it displayed. And then that's it. So we can just copy all of this, create a new script. So we file, new file, copy and paste. Okay, great. So now I'm choosing LCM, and I like to start with Van Gogh as a prompt, just because it's a classic. And so let's run this baby. So now we have the Python environment activated. Make sure that you see this parentheses. It tells you that you're in an environment. And now we can just do Python, webcam, LCM, SDXL Turbo, and tab to autocomplete, and enter. As you saw here, the little utility function that tells us whether we have CUDA. It said no, unfortunately. And then, do I have MPS available? I do. Okay, here we go. So here we have it. We have pseudo real-time diffusion happening right in front of our eyes. As you can see, as I get closer, the image gets bigger. And this is Van Gogh in the style of Van Gogh. It's kind of cool. Let's see what happens if I get up. So this might be a little slow for you, but this is actually pretty fast. Where we've come from, like, you know, even just like 3 months ago, 4 months ago, this was not that easy. This was not really possible. But this is insane that it's happening so fast. So as you can see, it reads my hands pretty well. And that's thanks to the edge detection. So there is one way to make this a little faster. And that's by changing the resolution. So instead of 512, we could do 384 as I had there. Intervals of 8. 84. And you'll notice that it's going to become a little bit faster. So you can see it is much faster now. Let's see what happens when I point it to the plant. Created windows. That's kind of cool. Okay, so that's fun. We can play with a couple of prompts, but we might as well just try SDXL Turbo now that we're here. So over here, we would change this to SDXL Turbo, and everything downstream will use this. This one seems fun. Let's try this one. I've already tried a couple, as you saw. Some work better than others. You're just gonna have to play around. That's part of the fun. Although be careful, you can spend so many hours wasted just experimenting and like playing with prompts. Be careful. Be careful of the rabbit hole. So that's fun. Wow. I'm a minion. It's kind of wild. Sometimes it's, oh, there we go. Depending on the noise strength, you might have different results. So right now I have it at 0.7, but you might want to reduce it a little bit so it's like a little bit more true to what's happening. But then it's sometimes doesn't get as creative as, that's a good one. But yeah, okay. So now that's LCM and SDXL Turbo. So that's fun. So we can quit that. So for StreamDiffusion, in order to make this tutorial real quick, since you'll have all the scripts and you'll be able to play around with this and modify them and do whatever you want, I'm just going to go quickly through this. It's basically very much the same as the other ones. The only difference is that StreamDiffusion was made with, was tested with 3.10, Python 3.10. So we have to go back to that environment instead. So I had a new tab here, and we have already activated StreamDiffusion environment before. Just to remind you to do it, how to do it, you would go source, and it would be slightly different for Windows. I'll probably do like some sort of thing here to show you how to do it there. Oh, actually, you know, something useful that you might haven't learned before is to deactivate, to leave the virtual environment, you do deactivate. And then just for practice, let's just go ahead and do that again. Activate the environment, go to bin, and hit tab if you don't remember what the commands are, because then you get a list of what's available. And activate right there, and then boom, here we are. Okay, so what we're gonna do now is run the StreamDiffusion, but I'll explain it real quick. So again, we have to install some dependencies. In the requirements file that you ran, I already installed StreamDiffusion for you, so everything should work fine. However, if you have a GPU, you might be able to use TensorRT. So in the requirements file for StreamDiffusion, you might want to uncomment this. This will help make things faster, but it will still be fast with a CUDA GPU regardless of this. So the lines that you want to comment back in if you have a CUDA GPU are over here. You want to uncomment this one. You also want to set torch device to CUDA. Over here I have a comment. And that's basically it. Everything else is going to be the same. Oh, another thing for StreamDiffusion, this is all sort of improv right now. Another thing for StreamDiffusion is that we need to modify a line in the pipeline for it to work with MPS. So if you have CUDA, go ahead, do your thing. You don't need to make this adjustment. But if you have a MacBook Pro and you're going to be using the MPS, then we need to modify something within package. So one of the nice things of having a virtual environment is that we can dig into it. So we go into the StreamDiffusion environment, we go to lib, we go to Python 3.10, we go to site packages, and we find StreamDiffusion somewhere over here. Okay, we find it. Then we go to pipeline, and we have to modify this. So we're gonna go here, we're gonna drag and drop it. This can be a text editor, and we're gonna go all the way to the bottom. And this line over here, we wanna check whether we have CUDA, and if not, then we wanna skip these steps. So this is a hack that is answered here. I can link it up right here. And yeah, so we're using this hack. It works well. So all we have to do is check this and write it here. And we add it in another section up here and down here. So we start it over here. And then we just move all of this inside. And then that's it. So we hit save. Okay, great. So now let's create a new script and let's just copy and paste things. We can call this webcam StreamDiffusion.py. And we're just going to copy what do we have here. I already explained it. I'm going to paste. And now we can run it. So let's choose a fun prompt. I tested a few. Which is one that I liked? Oh yeah, this one's fun. I've always wanted to be a porg. They're super cute. So let's see what happens. So right now the prompt is Star Wars porg, furry, cute Disney. So now we go over here. We're now in the, make sure that we're in the StreamDiffusion environment. And we can do Python, webcam, StreamDiffusion Py. There I am, as a porg. Kind of scary, to be honest. So cute. There's another cool one. There's another cool prompt that I like that worked kind of well. Oh wait, that's cute. Wait, side face. Oh, look at that. So cute. So another one that I liked was this one. I even labeled it good. So we go back here. We'll hit Python. Oh, that's sick. Look at that. That's scary. That's so scary. Damn, look at that. Even my hands are fiery. You can play around with a lot of things, like you can add props and it'll change things. So the beautiful thing about the future of filmmaking is that some of the generative stuff might involve doing weird, hacky prop stuff. So that changes things. What else could we use? I mean, you can use anything. Oh wow, look at that. That's pretty cool. All right. I mean, I don't know, should I try another prompt while we're here? Wearing a helmet, black mask. I tried this one, it was all right. I mean, that's part of the fun. You just get to experiment. Just keep experimenting, have fun. Kind of like Darth Vader, but not quite. It's kind of there. It's all right. But it's super fun regardless, right? We've covered how to do close to real-time diffusion. Although if you have a GPU, you'd probably be able to do it way closer to real-time. If anybody here does end up using a GPU, please send me clips of what you are able to accomplish. Oh, and one last thing. So even though this was a quick tutorial, if you like this kind of stuff, the sort of DIY AI kind of thing, do-it-yourself AI, my brothers and I have been working on the book that is going to be full to the brim with cool DIY AI kind of things. I'm not just talking about stable diffusion. There's an entire chapter dedicated to that. There's an entire chapter dedicated to music generation. There's an entire chapter dedicated to facial recognition. There's so much good stuff in this book, and we're very, very proud of it. My brother Serge has been leading this, and he's really created something quite beautiful. And you can actually pre-order the book. So if you want, I'll put some links on the description where you can pre-order it. And if you like stuff like this, let me know. I can totally make more videos like this. Anyways, thanks again. If you like this, hit that like button, subscribe, whatever you want to do, and I'll see you in the next one.